In this video, we are introducing basic differentiation formulas and rules. In the past, we tried to find the derivative of a function using definition, which was a limit of a rather complicated fraction. It was a lot of work to find the derivative. So here, we want to introduce some formulas that we can use to find the derivative. So by the way, all those results that we are learning in this video are based on the definition. People apply the definition, like the definition of derivative involving limit, to actually obtain all these results, and the results that later on we're going to learn about too. All right, so let's see. So the first result says derivative of a number, constant. We have a constant function, right? So derivative of a constant function is 0. So C represents some number, any number. Right? The second result is, I missed the prime. Second result says derivative of power of x is simply n times x raised to n minus 1. What happens is, you think of this, when you differentiate power, you bring the power n down to the front and subtract the power by 1. So that's how you find the derivative of any power of x. N represents any number. Can be positive, can be negative, can be whole number, can be a fraction. All right, we'll see examples. So now third result says if you can find the derivative of a function multiplied by a number, what you do is to copy down the number k, just find the derivative of f using whatever appropriate rules and the formulas. All right, so you can just ignore the constant as far as the differentiation is concerned. Well, I want to comment on the constants. So k here is a constant, c up here is a constant too. We usually use c to represent a constant term by itself, while use k to represent a number that's attached to something else, like times something else. All right, we'll see. Okay, later in the examples, the difference between constant here and constant here, how we treat them differently too. Next result considers the derivative of a sum or difference of two functions. The rule says you pretty much just differentiate respectively. You can put the differentiation through. All right. The last result we have here is about the derivative of an exponential function, e to some number times x. Okay, result says, well, you can have the k first, you can have the exponential itself. It's kind of interesting, k times e to kx. All right, before we see some examples, I want to just comment on, in mathematics, slight difference between formulas and rules. Sometimes we use them interchangeably, but there's some fine difference between them. Formulas in mathematics usually are specific ones, meaning formulas involve specific expression functions, while rules involve usually general, unspecified expressions or functions. So in this list, C is like a constant function, so that's considered as like a formula. Power of x is specific, so that's like formula. Well, this is exponential, that's a formula. Well, 3 and 4 involve unspecified f or g, so we would consider 3 and 4 as like a rule, differentiation rules, while 1, 2, 5 as formulas. That's a fine difference. Okay, so let's see some examples how we apply these rules and formulas to find the derivative directly. So we're not going to set up a limit and do complicated limit work to find the derivative anymore. Okay, so we have a bunch of examples here. In all those examples, we want to find the y prime, derivative of y. Just a common notation, I usually use y prime. Y prime is a derivative of y, which sometimes is denoted as dy dx too. So if you see that they want you to find the dy over dx, it's the same as y prime. All right. Okay, so first example, my function is y equal to 5. Y equal to 5, well, it's a constant function, right? So we're going to use this formula. And the first formula says if you differentiate constant to 0. So y prime is 0 in this case, or so just y prime equal to 0. There's actually no need for parentheses there. All right, so constant in this function 5 is an independent term. Its derivative is 0. It makes sense because it doesn't change. As we learned before, derivative represents the rate of change. So if the rate of change is always 5, of course, the rate of change is 0. Now let's look at the second example. Okay, so second function we have is y equal to 4x plus 4. Now I purposely have a 4 here and a 4 here. You're going to see we're going to treat them differently. Meaning they're both constants. As a matter of fact, same exact constant, right? That's how we do it. Well, first of all, this is a sum of two terms. So we're going to use this rule first, derivative of a sum of two expressions, two functions. Okay, so the rule basically just says we'll differentiate respectively. Differentiate the first one, differentiate the second one with the same plus or same minus. All right. So we're going to find the y prime. Now, this is the function itself. Once we start to use the rule formula to find the y prime, then we have to start new line saying y prime equal to, you cannot just continue with this with the equal sign saying, okay, we're going to have derivative, right? You must have y prime. Okay, so how do we find derivative? Like we said, we're going to find the derivative of 4x. 4 is a constant, so we're going to copy down this 4. Factor, because it's 4 times x. Remember this rule back here? If I have a constant attached to something, anything, when differentiating, you're going to copy down the k first and just do your differentiation however you do it. So we copy down the 4, try to just differentiate this part. What's the derivative of x? What is x? X actually is the first power. So x is like 1 here. Okay. How do we differentiate that? Well, its power will bring the 1 down. We don't need to write it down because it's 1. And then subtract. Subtract by 1. Always subtract by 1 when differentiating power. Okay. Plus, now, what's the derivative of 4? This term. Well, this 4 is by itself. So we would consider this as C. We would consider this as a C term. And this guy as K because it's attached to something else. But anyway, so how do we differentiate the constant term? 0. All right, so the answer, if we write down, it's 4 times x to 0th power is 1. So it's just 4 times 1. That's just 4. All right. And in this example, we actually also will kind of have this very special result. So x to the first power differentiate is 1. It's a kind of a special, unique because kind of we don't see power because it's the first power. Sometimes people get confused. You say what power? How come it's not like a x to the third power. Clearly you see 3 here and you say, hey, yeah, formula, bring 3 down, subtract power by 1, you get the derivative, but without seeing any number when it's a first power, somehow some people become panic. All right, so let's see next example. We have a function that's a polynomial involving 3 terms. So first of all, again, we're going to apply the rule here. It says if you're going to differentiate the sum or difference of terms, you just differentiate every term. So now let's differentiate. Okay, we are differentiating, so we're going to have y prime equal to, starting a new line, y prime equal to, so we're going to differentiate 6x squared. 6 is a constant, like the k kind of constant. So copy it down, power, simple, bring the 2 down, reduce power by 1. Second term, negative 3 is like a k constant, derivative of x. See, we see actually differentiation of x a lot. That's why I commented on this on the side. So derivative of x, as we see here, is 1, so it's just 1. You don't need to write it down. It'd be 3 times 1 is 3. Well, 2 is like a c kind of constant. It's a constant term by itself, so derivative of that is 0. Is it times 1 plus 0, and write another 9. You're going to simplify this anyway. 6 times 2, so it's fine. So 12x minus 3. All right. All right, I can see more examples. So D, function y this time is a difference of 2 terms, and none of this term looks familiar. Recall the formulas we had. We had derivative of constant, derivative power. As far as a specific expression is concerned, we have derivative exponential, right? Well, 3 and 4 involve just general function f or g. So how are we going to do it? What are those guys? Well, it turns out this is actually power. This can be turned to a power too. So in the end, we're going to use derivative of power formula here. Okay. So first, we're going to rewrite. When we rewrite, it's algebra, so it's the same exact thing. We continue with the equal sign. So equal to, even if you're going to do the simplification here, you can just say equal to, right? Not y prime yet, so just rewrite. Cubic root of x is x to the 1/3 power. Four over square root is the same as 4 over half power. Okay, so now you can see the first term is already in the form of power. We can go ahead and differentiate. We could. Actually, I'm going to wait. Well, the second term, the reason is the second term is not ready. You cannot differentiate the fraction right away with x in the denominator. There's no formula, no rule yet for us to do it. Okay, so you cannot simply say the bottom power, right? Half, you bring like the half down, subtract 1. You cannot do that in the denominator. Okay, there's never such rule. So what we're doing is we'll do more algebra to turn the second term into something we can handle now. So first term is already good. Second term, I'm going to copy down the 4 and move the power to the top as negative. This is pure algebra. So this problem, basically, we have to rewrite the function, prepare terms in the function first. Now it's ready. So we're going to start a new line, just say, okay, then y prime is, now the first term, the power, so bring the 1/3 down, and subtract the power by 1. 1/3 minus 1 is negative 2/3. Second term, 4 is a constant factor. We copy down the 4. And then the power of x, we use derivative power to bring the 1/2 down and then reduce power by 1. Negative 1/2 minus 1 and negative 3/2. So this would be the answer. You could multiply, simplify the numbers, like 4 times half is negative, positive 2. Actually, the powers, you don't need to put them on the bottom. All right, so as far as differentiation is concerned, we're done. This is good enough. Okay, and this example shows that a lot of times, the expressions, terms involved in the given function are not ready. and somehow through some algebraic rewriting, we could turn it into something we could apply existing formulas to find the derivative. Okay, all right, so next we're going to see a fraction, y equal to this rather complicated, a fraction here. And obviously we don't have any formula for that kind of thing. You look at here, this is all that are available. So how are we going to do it? Well, turns out again we need to rewrite first. Eventually we'll be able to apply some of these results to find the derivative. All right, for this function, we'll rewrite. We'll simplify by doing what's called termwise division. As a whole function, right now it's impossible to find the derivative, but we divide x to the third power through, called the termwise division in algebra. So first term 6x to the fourth power divided by the bottom. Second term 3x squared divided by the bottom. The last term 4 divided by, you have to divide by the denominator everywhere. This way we will be eventually in this expression turn everything to some kind of power and be able to differentiate them all. So the first fraction now is 6 times x. We cross out third power from top and bottom. The second term, well, let's copy down the 3 first. Second term, the first power of x is concerned is the second power on top and third power on bottom. So if we use property of exponent, we're left with the x to negative first power. Initially, if you cross out the x squared, you would have 1x on the bottom left, but you cannot differentiate anything on the bottom directly, so got to turn it up. All right. The last term, again, we cannot have anything on the bottom. We're going to differentiate, so just move it to the top as a negative power. So now it's ready. You can see each every term basically is some kind of power of x. So now we start to differentiate, start a new line with the y prime leading the expression. So y prime equal to, and differentiate 6 times x, 6 times 1, remember derivative x, we see here again. Copy down the negative 3, bring the negative 1 down, get the negative 2. Always subtract 1 from the power. And here, copy down the 4, bring down the negative 3, x reaches the negative 4. You always subtract 1, and this is the answer. Of course, again, if you want, you can multiply negative 3, negative 1, you can multiply negative 4, negative 3, for further simplify. But for now, we just want to see how to apply the right differentiation formulas, apply those formulas correctly to get the differentiation done. Simplification is not required. It's important. It is important, but it's not our focus. And then later on, as a matter of fact, we will have to simplify the result to do other things. So right now, let's just stop when all differentiations are done. All right, so this is the focus of this lecture, this video, with the simple, basic differentiation formulas and rules. We can rather easily find the derivative of actually many functions now, primarily polynomial functions, because polynomial functions consist of powers of x, and we can easily differentiate, and sometimes even with the radicals involved, with the complicated fractions involved, we can do it too. All right, let's just stop here.